In this lesson, we're going to talk about Earth's shape, the spherical Earth, and how it got that way. If you take a look at the Earth that's provided right here, I want you to take a close look at it. Why is Earth spherical? This image of Earth was taken from space. I want you to notice Earth's shape and the wispy clouds that you see that surround part of the planet. What else do you notice about Earth? I want you to remember from your last lesson about gravity and how the Earth was formed and why our Earth has a solid core with an outer core that is liquid, why we have our magnetic field around us, and all the things that formed Earth the way it was. What you need to remember is gravity formed and maintains the spherical shape of the solid Earth. Gravity also influences the shape of Earth's atmosphere and the hydrosphere. So what I want you to do is, I want you to pause this. I want you to write these 3 questions. This one here. What characteristics of Earth can you see in the picture? Remember, a characteristic is what makes it it. What makes you you is your characteristics. Okay, the second question I want you to do is this one. What keeps living things, land, water, and gases in Earth's systems from flying off into space? The last one I want you to take a look at is this one, and I want you to write it down and answer it. Why are air and most of Earth's water on the outside of rocky Earth instead of on the inside? Those 3 questions I want you to take and write in your science journal using information that you already know, and I want you to answer all 3 of those questions, please. Okay? The other thing I need you to do for me, I'm going to take this and make it small. I need you to write your vocabulary. Those 4 terms, those 4 vocabulary terms, are the words that we're going to be focusing on for this lesson. Sphere, geosphere, gravity, and density. Write the vocabulary down, and as we go through the lesson, I want you to please write the definition when you find it. Okay? The main things we're going to be concentrating on are these essential questions, which we will be putting up on the board in class so that we can make sure we're answering them by the end of this lesson. Our key concept questions or essential questions are, what are Earth's major systems and how do they interact? The other one is, why does Earth have a spherical shape? These 2 questions you need to write in your science journal under essential questions. You're going to write essential questions, then you're going to write this question, and we can answer them together, or you can answer them as soon as we're done with the lesson. Those are the things I want you to do presently.
Describing Earth. Imagine standing on a mountaintop. You can probably see that the land stretches out beneath you for miles. But you cannot see all of Earth. It is far too large. People have tried to determine the shape and size of Earth for centuries. They have done so by examining the parts they can see. Many years ago, people believed that Earth was a flat disk with land in the center and water at the edges. Later, they used clues to determine Earth's true shape, such as studying Earth's shadow on the moon during an eclipse.
You might find it difficult to imagine that anyone ever thought Earth was flat. So what I want you to do is I want you to think about some questions that I have. Okay? I want you to think and put yourself in the time of ancient civilization. And I want you to remember what they had and what they didn't have to their ability to use to determine certain things. So the question I want you to answer, I will be moving some things, hold on. Question I want you to answer is this one, or these 2. Hold on just a second. These 2 questions here. How might an ancient civilization who lived in the center of a continent have described the shape of Earth? To the best of your ability, please write that down and answer the question. Remember that you can always pause this to write your question and answer, and then start it again. The second question is this one right here. How could you determine the size of nearby lake without using advanced technology? Without using anything that we have, how could you personally determine the size of a nearby lake without using all of the technology that we have today? So answer those two questions. Okay? And then we're going to move on here so that you can get the rest of the information.
The size and shape of Earth. Now there are better ways to get a view of our planet. Using satellites and other technology, scientists know that Earth is a sphere. A sphere is shaped like a ball, with all points on the surface at an equal distance from the center. But Earth is not a perfect sphere. As illustrated in Figure 1, Earth is somewhat flattened at the poles, with a slight bulge around the equator. Earth has a diameter of almost 13,000 kilometers. It is the largest of the 4 rocky planets closest to the Sun.
Okay, so that information should help you to determine the shape of Earth. Is that where we end? Absolutely not, because we have to write some vocabulary words so that we can understand a little bit more of what our Earth is like. So, at this point, I want you to use this information here, which again is a vocabulary word. And I want you to write your vocabulary word and its definition, please, in your science journal. A sphere is shaped like a ball with all points on the surface at an equal distance from the center. Now just remember what was said. Okay? Equal distance from the center. But our Earth isn't like that. We're slightly irregular. We're more pushed in at the tops and more bulged out on the sides. Okay, so now I'm going to do this. I'm going to do this. Okay? I'm going to ask you, from the information that you just heard, what is the shape of Earth? Go ahead and write it in your science journal. Answer the question, if you possibly can. You should be able to from the information that we just talked about. Also, how do scientists study the shape and the size of Earth? Let's see if you can answer that one. Shouldn't be difficult. You're all very smart, and you've all had a little bit of knowledge before, so use that knowledge to answer the questions that we have in front of us. Okay? And then we're going to move on.
Earth systems. Earth is large and complex. To simplify the task of studying Earth, scientists describe Earth systems as shown in Figure 2. All of these systems interact by exchanging matter and energy. For example, water from the ocean evaporates and enters the atmosphere. Later, the water precipitates onto land and washes salts into the ocean. The hydrosphere is water on Earth's surface, underground, and liquid water in the atmosphere. Most of the water in the hydrosphere is in salty oceans. Fresh water is in most rivers and lakes and underground. Frozen water, such as glaciers, is part of the cryosphere, which overlaps with the hydrosphere. The atmosphere, the hydrosphere, and the cryosphere. The atmosphere is the layer of gases surrounding Earth. It is Earth's outermost system. This layer is about 100 kilometers thick. It is a mixture of nitrogen, oxygen, carbon dioxide, and traces of other gases. The geosphere and the biosphere. The geosphere is Earth's entire solid body. It contains a thin layer of soil and sediments covering a rocky center. It is the largest Earth system. The biosphere includes all living things on Earth. Organisms in the biosphere live within and interact with the atmosphere, hydrosphere, and even the geosphere. Key concept check. Identify Earth's 4 major systems.
Okay, so using this diagram that I've been pointing at, these things right here, I want you to take a look at each one of them. each one of them has a small description underneath of it. You might think Earth systems are separate layers of Earth. Okay? When you think about it, let's take a look at these questions. 1, 2, 3. Okay? Answering them in your science journal, using them interacted with this chart. Okay? So I want you to identify Earth's major systems. Earth's major systems. Using that chart, write it in your science journal and answer that question. I also want you to answer the next one, which is, which Earth system is farthest away from the center of Earth? Farthest away from the center of Earth. And the last question I want you to answer would be, how are Earth systems involved in a summer thunderstorm? Okay? How are Earth systems involved in a summer thunderstorm? Write those questions down. Closing some things up here, making them a little smaller. Remember, you can pause the video and restart it again. Now, one thing I want you to do, I'm going to close this, and I'm opening this, making this a little larger, because geosphere, which is the term that's there, is one of your vocabulary words. Okay, geosphere is Earth's entire solid body. Earth's entire solid body. Please write that down in your vocab and make sure you have it. Okay, and then we'll be moving on.
How did Earth form? Earth formed about 4.6 billion years ago, BYA, along with the Sun and the rest of our solar system. Materials from a large cloud of gas and dust came together, forming the Sun and all the planets. In order to understand how this happened, you first need to know how gravity works. The influence of gravity. Gravity is the force that every object exerts on every other object because of their masses. The force of gravity between two objects depends on the object's masses and the distance between them. The more mass either object has, or the closer together they are, the stronger the gravitational force. You can see an example of this in Figure 3.
Okay, so Figure 3 is this one right here. Things I need you to understand are that if you notice A and B, you have three objects that look like planets or balls that are the same size or mass, and you have one that's larger. The arrows that are going up through them are showing you that they are the same distance. Their axes are the same distance apart. So this one and this one are the same distance apart as this one and this one. If you take a look at the arrows, you have thin arrows here and thicker arrows here. The reason for that is because the two objects in row A, which is this one here, are the same distance apart as the objects in B. One of the objects in B, which is this one here, has more mass. It creates a greater or stronger gravitational force between the two objects. These two objects has a greater gravitational force than these do, even though they're the same distance apart. Okay, so let's take a look at C, which is these two, and D. All four are the same let me try this again. All four are the same mass, but if you notice, these in C are closer than these in D. All four objects have the same mass. The two objects in row C are closer together, as you notice. There's the axis there and there versus the axis here and here. So the two objects in row C are closer to each other than the two objects in row D, and therefore have a stronger gravitational force between them than these two do. Okay, so the thinner arrow, longer, stretching, less gravitational force than the thicker arrow. So the thicker the arrow, the more gravitational force there is. So what I need you to know is mass and distance. Mass, which is these here, this is a smaller mass than this one, and distance, distance being the distance between something, affect the strength of gravitational force between the objects. All right, so the strength of those two, the strength of these, because their mass is not as large as the mass of this one, the gravitational force is more than the gravitational force here. Even though all four of these have the same mass, the gravitational force in this one is more than this one because they are a closer distance than these are. Okay? Closer distance. What I want you to do now, I'm going to close that down a little bit. Oops. And we are going to give you a definition, which is this one right here. All right, so your definition, gravity. Please write the definition as well as the vocab word. Gravity is the force that every object exerts on every other object because of their masses, just like the diagram we just talked about. If you need to, go ahead and pause this. Write your definition, making sure you have it so that you can do well on the vocab quiz, and then restart it again. Okay, so now that you have that written down, I'm going to make this smaller. And I'm going to bring up the questions, the 3 questions that I always ask. Okay, write these in your science journal and answer them, please. What is gravity? That would be the first question, that one there. The next one, if you notice, is a check to see if you know the information that was just provided to you. What factors affect the strength of the gravitational force between objects? That one refers to this chart. Okay, if you need to, go back and look at the chart and then answer the question. All right, and the third one, this one here. How has the force of gravity affected the shape of Earth? Sounds familiar. Sounds like something we maybe need to learn for this lesson. Okay, pause it, write those questions in your science journal, restart the information. Okay? All right.
The force of gravity is strongest between the objects in row B. Even though the objects in row A are the same distance apart as those in row B, the force of gravity between them is weaker because they have less mass. The force of gravity is weakest between the objects in row D. Reading check. What factors affect the strength of the gravitational force between objects? As illustrated in Figure 4, all objects on or near Earth are pulled toward Earth's center by gravity. Earth's gravity holds us to Earth's surface. Since Earth has more mass than any object near you, it exerts a greater gravitational force on you than other objects do. You don't notice the gravitational force between less massive objects.
Remember, as we talked with our last lesson, gravity has an effect on Earth, and actually had an effect on Earth's how it was formed on the inside. Remember, your more dense material, the more mass material, sinks to the middle. Your less dense material is on the outside. So in this case, the core would be the most dense in Earth, and the crust material would be the less dense material for Earth.
The solar nebula. The force of gravity played a major role in the formation of our solar system. As shown in Figure 5, the solar system formed from a cloud of gas, ice, and dust called a nebula. Gravity pulled the materials closer together. The nebula shrank and flattened into a disk. The disk began to rotate. The materials in the center of the disk became denser, forming a star, our sun. Next, the planets began to take shape from the remaining bits of material. Earth formed as gravity pulled these small particles together. As they collided, They stuck to each other and formed larger, unevenly shaped objects. These larger objects had more mass and attracted more particles. Eventually, enough matter collected and formed Earth. But how did the unevenly shaped young planet become spherical? Early Earth. Eventually, the newly formed Earth grew massive and generated thermal energy, commonly called heat, in its interior. The rocks of the planet softened and began to flow. Gravity pulled in the irregular bumps on the surface of the newly formed planet. As a result, Earth developed a relatively even spherical surface. Key concept check. How did Earth develop its spherical shape?
Okay, so this information here just gives you a little idea as to what gravity does or how gravity played a part in forming our Earth. Okay, gravity's pretty important to us. Keeps us from flying out into the solar system, into space. Holds our planet together. Holds our solar system together. So it's very, very important, key information. Okay, so here's what we're going to do. I'm going to pull this down. Okay, we are going to talk a little bit about some questions that I want you to answer. Okay, let me pull this questions up here. This one here. I'll make these smaller since we've already gone through them. Okay. Okay. What force caused the planets to take shape? First question. Writing these questions down in your science journal, using the information that you know, and answering those questions. So what force caused the planets to take shape? This one here. The second one is a check of the information that we just covered. The solar system formed from what type of a cloud? This one right here. So you may have to go back and listen to the information and write your answer again, okay? The next one, or the last one here, is this one. Why did the outer planets continue to revolve around the sun? So those three questions, I want you to answer them in your science journal. Okay. The next one, do this. Remember, you can always pause, write the questions, and restart again. The next one, oops, not that one. How about if we try a different one? How about, oops. How about this one? Okay. This one right here. Notice key and the check. Key concept check question. This is one that we must answer or have the information for by the end of the lesson. Okay. So how did Earth develop in its spherical shape? How did it develop its spherical shape? Okay. The next question I want you to write down is this one. How might Earth look if its interior had not melted and flowed? How might it look? You can use some of the information you knew from the last lesson in reference to the lithosphere and the asthenosphere, which is in the mantle, to answer some of that question, okay, because that was from the last lesson. But this information here and this information here needs to be in your science journal. You need to pause it if you need to, and answer the questions. Restart it again, okay? So, those questions are ones we talked about. Okay, so the next thing we want to talk about, after I move everything around, will be density. Okay? Density is pretty important, and we're also going to talk about doing some mathematics. Some of your favorite things to do, I know, in science is mathematics. So, let me move some more things, get the next lesson parts up for us to use, and then we will be ready here. Okay? We're going to talk about Earth systems.
The formation of Earth's layers. Thermal energy from Earth's interior affected Earth in other ways as well. Before heating up, Earth was a mixture of solid particles. The thermal energy melted some of this material and it began to flow. As it flowed, Earth developed distinct layers of different materials. The different materials formed layers according to their densities. Density is the amount of mass in a material per unit volume. Density can be described mathematically as D equals m/V, where D is the density of the material, m is the material's mass, and V is its volume. If two materials have the same volume, the denser material will have more mass. Reading check. Can a small object have more mass than a larger object? Explain your answer. There is a stronger gravitational force between Earth and a denser object than there is between Earth and a less dense object. You can see this if you put an iron block and a pine wood block with the same volumes in a pan of water. The wooden block, which is less dense than water, will float on the water's surface. The iron block, which is denser than water, will be pulled through the water to the bottom of the pan. When ancient Earth started melting, something much like this happened. The dense materials sank and formed the innermost layer of Earth. The least dense materials stayed at the surface and formed a separate layer. The materials with intermediate densities formed layers in between the top layer and the bottom layer. Earth's three major layers are shown in Figure 6.
Okay, so what I need you to remember is our lesson from the prior lesson, the lesson that we had already gone over and tested over, about density. You need to remember that the more dense materials sank to the bottom of Earth, which is what this is talking about, and the least dense materials stayed on the top of Earth. Okay? Kind of like when we discussed the Italian dressing. When you shake the Italian dressing bottle, everything mixes together. But if you leave it set, some materials float on top and some sink to the bottom, and you can see a distinct difference in the layers. That's density. The more dense something is, the further it's going to sink in the bottle. The less dense, which is probably the herbs, are going to float on the top. Okay, that's what this picture is showing us. Okay, so go ahead right now and write your definition, which is here, of density. Okay? Density is the amount of mass in a material per unit volume. Now, we're going to have to figure this out as to how to calculate this, because there will be some calculations on the test, because you can calculate the density of something. Okay, so we're going to learn to do that in this lesson. There's 3 other things I need you to write down question-wise, especially for this part, and that's these. Okay. Can a small object have more mass than a larger object? And it wants you to explain your answer. So please write that down, explain your answer, and at least 1 or 2 sentences, please. Okay, at least 1 or 2 sentences. The next question I want you to write down is, does a small gold bar have a different density than a large gold bar? This one right here. It also wants you to explain. Okay, to the best of your ability, do both of those. And then the last one is this one here. Are most rocks less dense or denser than water? It also wants an explanation. So these 3 questions, write that information down in your science journal and answer it to the best of your ability. Okay? Moving along. Now, we're going to talk about how do you calculate density. In this lesson, it gave you a formula. Okay? I'm going to do my best I'll put it in green. I'm going to do my best to help you to understand this. Okay? So the formula itself is D equals M divided by V. Density equals mass over volume. Problems that you're given will provide you with one of these 3 variables. One of these 3, density, mass, or volume. Okay? I try to remember this by looking at the diagram itself. I know that density, which is this one, is equal to heart. You may not see the heart, but the heart is there. I'm going to go ahead and show you. Okay, your M, and your V together form a heart. It's dividing the heart, so you know your mass is on top and your volume is on the bottom. Okay, so density equals mass times volume. And that's going to be the formula you use when you write this information down. Okay, because we are going to do this practice right here. It walks you through one step of the equation, and then it asks you to do another one, and it provides you the information that you need to figure it out. Okay, so you're not going to get that information from this. You're not going to get your answers on this one. We will talk about them in class. But it wants you to compare the masses of substances, and it's useful one, look, this one right here. Comparing the masses of substance is useful only if the same volume of each substance is used. To calculate density, divide the mass by the volume, mass divided by volume. The unit for density is a unit of mass such as G, which is grams, divided by a unit of volume such as cm3, which is centimeters cubed. And it gives you an example. For example, an aluminum cube has a mass of 29 grams and a volume of 10 centimeters cubed. It wants you to find the density. The density of aluminum is 27 divided by 10, so your density is 2.7 G divided by cm cubed, or grams per centimeter cubed. Take this information right here, okay? Take this formula right here, plug in your information. A chunk of gold with a volume of 5.00 centimeters cubed has a mass of 96.5 grams. It wants to know the density of this gold. You're going to figure it out, and then we're going to talk about it in class. Okay? Don't be shy. Please work at it. I know math isn't one of the favorite subjects of anyone, but math is part of science, and we do need to work at it. Okay? So please attempt this question using this formula. Okay? And we will work it out. Okay, so I'm hoping you understand the math problem. Okay? I know that we're going to go over it in class. Relax with it. Do your best. Okay, so now it's time to do the lesson review. Okay, so this time, instead of just writing your answer, I would like for you to write the questions down as well as your answer. Okay, the questions as well as the answer, except for this one, and all you have to do, no, we're going to go with this anyway. I'm going to hold on to my facts, and I want you to write all of the questions as well as your answers. I want you to draw the diagram, please. The diagram. And on this one, I want you to do the math problem. Okay? I hope that you've learned a lot in this lesson. This is the lesson review. So if you have questions, you make sure you ask them while we're in class, and I will be glad to answer them for you. So at this point, we're going to go ahead and have you do lesson 1 review. And I hope you've enjoyed your lesson.